Hello, and welcome to this contribution to Gender Summit 19. My name is Jonathan Dawes. I work at the University of Bath, and I'm an applied mathematician, so this is going to be quite a data-heavy presentation. So I'm delighted that you have it on these slides, so you can review it at your leisure. I'd like to thank the organisers very much for the invitation to make this contribution. And I'm going to talk about the Sustainable Development Goals as a network problem and look at interlinkages and see which of those links one might wish to prioritize, which ones matter the most. So an outline of the talk, it's essentially in three parts. I'm going to start by going to review the report from the ICSU and ISIC organizations, now jointly the International Science Council, from 2015, shortly after the SDGs were published, and then compare that with a much more recent Global Sustainable Development Report from last year. There are some common elements that I'll try and draw out, and then we'll look at perturbing that network structure to try and see which perturbations drive the sort of largest improvements. And there are various ways that one could define improvement. So either the overall growth in progress on the goals, perhaps, or demanding more equal progress across all the goals. And then there'll be some conclusions. So this slide is in the deck really just so that you have it to refer back to. I'm going to point out that actually the individual goals I'm going to summarize by these two-letter codes just for ease of presentation, and so having this to refer back to is also useful. It's a very complicated system, all 17 together, having of course 169 targets below the goal level. And so there are inevitable questions about the consequences of such a broad agenda and how parts of it link together. So that was what the ICSU report from 2015 tried to analyze through expert analysis from a scientific perspective. And it's, I feel, a very valuable report because it's one of the few that looks across a number of goals, goals 1 to 16 in this case, with a common methodology. So there's a sense of at least a common framework and analysis for goals 1 to 16. And their conclusions were, in summary, that a lot of the goals were not very well quantified, and there were a lot of questions about the interlinkages between goals. Where are the trade-offs and the co-benefits that arise? This report, of course, was reviewed and commented on by the UN, the Department of Economic and Social Affairs. So this is from March 2015, where they take the ICSU report and try and present that as a network diagram. So you see that here on the left. And this, to my mind, is a little bit lacking because it doesn't convey a sense of the directionality of these links, what is upstream and what is downstream. And it also doesn't tell me easily which of these connections are trade-offs or co-benefits, are negative or positive. And they come out with the conclusion that poverty is the most central node in the network, but I'm never quite sure how that arose. So I have a paper that you can read for more details on this, but taking the ICSU report as a starting point, and taking their commentary and making that a more quantitative analysis, one can take the linkages that they describe and produce a quantified network adjacency matrix, as it's called, from that. And so you end up with a picture like this, where the white areas are essentially a link of weight very close to 0, so almost no link at all, or absolutely no link at all. And blue colors, dark colors indicate negative links. So here there's a negative influence of progress on goal 2 on goal 14. And then there are a lot of light colors that indicate lots of positive reinforcement. So progress on goal 12 should drive greater progress on goal 2. So you read this by saying that the goals labeling the columns are the influencers, and they influence the goals that label the rows here. So influences go sort of this way. And almost all of those are positive. So this network would have a kind of self-consistency property if any progress on any one of the goals lifted all the others. And sitting behind that mathematically is a very simple model of this form, so a kind of linear set of equations that relate current progress on the goals, so the current value of these quantities xj, to their rates of change. Okay, so if you've got good progress at the moment and you have reinforcing positive links in our adjacency matrix A, then that should drive further positive progress, and these rates of change should be positive so that you make more progress in time. And essentially the property of A that we're after, that drives the behavior, at least at long times, is known as this leading eigenvector. So I'm not going to go into the mathematics anymore, but it's this kind of single quantity describing the progress on A that I'm going to try and pull out. So if you calculate that leading eigenvector for this matrix A for the ICSU network, you end up with this solid line here. And this describes essentially positive progress on every goal, but negative progress on life below water, goal 14 here. So that means that everything else essentially is sort of lifted by the other goals apart from goal 14. And this conclusion is robust. If you replace all the weightings by +1 and -1, you end up with this dotted line, which has essentially the same form. It's got high entries for goals 1, 2, and 3, and then lower entries for other goals and a negative component for goal 14. So if we now turn to the GSDR report, it's a much more comprehensive literature survey. 177 journal papers and reports have gone into that. And they published an interaction matrix of essentially the same kind as computed for the ICSU report. This happens to be just flipped. So the influencing goals are now these rows. And so you read this by saying goal 13, for example, here on climate change, has a large number of negative and positive influences on goal 14, life below water. And the orange here denotes negative influences, and the blue denotes positive influences. So if you average over those positive and negative contributions, and you flip it around to be in the same orientation as what I showed you before, you end up with this adjacency matrix. It has a lot in common with the ICSU matrix, many positive entries, but a few that are kind of significant, a small number of negative entries, and again, a smaller number of those that are significant. The negative entries you can see again picked out in these dark blue colors. So there's one here, influence of goal 13, climate, on goal 14, life below water, on average, and an influence of goal 1, no poverty, on goal 15, life on land. So if I put these next to each other, what is interesting is that there's a degree of structural similarity here. So there's a very sparse area in this lower left where there are very few entries, and some of those are small and negative, and there are very few entries here as well. And in contrast, there's a large positive piece up here, and there's a large positive contribution here. So what this indicates is that in both these cases, the network really decomposes into a collection of goals 4 up to 17, which have their own internal structure. And then they drive through these entries here, progress on goals 1, 2, and 3. And that's why the progress on goals 1, 2, and 3 tends to be higher, because it's driven by progress on the later goals. And exactly the same structure is shown here in the ICSU report, but there's very little feedback. And this sparse area here indicates that there isn't so much feedback from 1, 2, and 3 onto goals 4 up to 17. So we can check robustness for this by sampling. So there's just a sense of trying to investigate those positive and negative entries and not just cancel them out. And you see here that there's potentially a problem on the water goal and also on life below water. So goals 6 and 14. This is called a Violin plot. It's a kind of vertical set of histograms. So this is like a kind of a histogram plotted vertically for each goal. And if we compare these leading eigenvectors, then there's again similarity here. So we have 3 high components for goals 1, 2, and 3 for the GSDR and the ICSU reports. The GSDR report has a larger component here on the growth goal, but then they're very similar, and there's a slight dip again on life below water. But the GSDR leading eigenvector does have this self-consistency property. So all these components have the same sign. They're all positive here. So that's good. But we make unequal amounts of progress between different goals. So one of the aims of our perturbations to that network could be to try and design interventions that give us more equal growth between the different goals or faster overall growth of the system as a whole. And there's a mathematical answer to those questions. I've just plotted the results here. So starting with the ICSU network, if we perturb these goals with the light colors, then we get faster overall growth. And if we perturb these goals here with the light colors in the right-hand panel, we get more equal growth. And there's a very similar story when we look at the GSDR network as well here. So there's an interesting coupling in the network itself between goal 6 and goal 12, which means that they have very similar behavior. So perturbing goal 12 and perturbing goal 6 gives us very similar results. One set of interesting perturbations is described by the Sustainable Development Solution Network's 6 transformations, which I've just summarized here. And we can then look at the effect of those 6 transformations, thinking of them as a perturbation to the internal dynamics of that goal itself on the rest of the system. So for example, if we look at transformation number 1 that highlights education, gender equality, and inequality goals, we can see that we do indeed make progress on education, gender equality. These are the positive dark bars here, here, and then there's another one here, and there are small increases on many of the other goals. If, however, we choose our perturbation carefully and we design in a method for goal 3, so it's healthcare reinforcing gender equality, then we get the yellow bars, and the yellow bars are generally much higher than these dark blue bars. And that indicates that we've chosen a much more effective way of perturbing the system in order to achieve this kind of leveling up. So these are perturbations from the leading eigenvector that I showed you before. So this is trying to reduce 1, 2, and 3 a bit and bring everything else up to balance it. So that's what we're showing here. And so a well-chosen perturbation does better overall. So just to conclude, the 2 reports from ICSU and the GSDR produce networks with a common structure that actually you have goals 4 to 17 driving 1, 2, and 3. And so the challenge is then to design what I've called here kind of reverse interlinkages, where we drive from 1, 2, and 3, we connect those more into 4 up to 17. So that's a kind of design and a policy problem now in order to identify these well-chosen linkages for one particular situation and work out how to make that a policy recommendation in a parsimonious way. So rather than trying to hit the whole agenda, I suppose here my thinking is to pick off individual pieces of the agenda where we can have the biggest effect. And there's detail of this in a paper published today. Thank you very much indeed for listening.